Erin, do you have anything?
Welcome everyone to our open drone map presentation here in November. If you haven't checked it out, we have a save the date page on the GSSIG website for our upcoming spring conference. But other than that, take it away. Thank you.
Okay, thanks. I can walk through the agenda, Brett. Sound good? All right. So we'll just spend a couple minutes on introductions, who we are, Brett and myself. We'll provide some introductory material for Open Drone Map. I'm just assuming everyone's kind of starting from scratch on this. It'll be pretty brief if you already know a bit. But we will spend a little time just essentially starting from scratch and saying, what is Open Drone Map? What does it do? We'll walk through in a fair amount of detail the 2D and 3D outputs from the software and show some examples of those. We'll talk a bit about what's new in the ecosystem, as well as the Open Drone Map community. And if you're interested in learning more, we'll help you get connected with those resources as well. Brett, go for it.
All right. So those of you on the board know me. We may not know is that for the past year or so, I've been sort of trying to spin up being an Open Drone Map contributor. I don't code very well, so a lot of my contributions are very small. But on top of being a contributor to the code base, I am mainly responsible for the documentation. So if any of you have read the docs or, are really curious to explore Open Drone Map after this and run into issues with the docs, please feel free to reach out directly to me with any sort of things that are lacking or you think you might be improved upon. It is expanding, so there are a lot of things that are simply just not fleshed out yet. I am the IT specialist and community manager for UAV4Geo. They are a company run by Piero Toffanen, one of the co-founders of Open Drone Map, who co-founded along with Stephen Mather. So UAV4Geo provides consulting and software improvements to the Open Drone Map code base. If you've used it recently and you've used an easy installer to run it on Windows or Mac OS, that was something that UAV4Geo created and contributed to the Open Drone Map community. And these are value-added services. Another thing that they added was the Lightning cloud processing network to align it more with product expectations like Drone Deploy or Pix4D Cloud. So in this role, if you email and you have a problem, you're probably going to catch me. If you land on the forum, I'm going to do my best to make sure that you're introduced, you're welcome, and I help you. Or if I can't help you, we try to get you in front of the people who can help you. I am a FOSS advocate, so that would be free open source software. This is a journey that has been years in the making, spurred on by my time doing my master's thesis. But I do believe very firmly that people should have access to the tools they need to be successful. And I believe that using those tools, people should be able to share information and knowledge to empower one another within their communities and even without their community, beyond the boundaries of their community to help people, because there's just a wealth of expertise and information and experience all throughout the world. And this sort of lowers the barrier to that. I'm a Part 107 certified UAS pilot, so that means I get to play with fun toys. I have not been doing it super recently, but in my profile photo, I am using a 3DR Solo with a modified NDVI camera to fly a grower's field. Love it. It's great. It's a great intersection of tech and fun. I'm a board member for GIS-SIG, who is the organization that's hosting this conference today. In that capacity, I want to try to increase our outreach with the community around open source and other initiatives like that in Open Drone Map. So this is part of that today. And on the fun side, I take bad photographs. I play my theremin even worse. It's actually right back there. And yeah, gaming, biking, anything. I love being outside. And also paradoxically love sitting at my desk. So on to Corey.
Sorry. I'm just learning to use my computer. I'm also an Open Drone Map contributor, and I am also fairly small times in terms of my contributions. I mainly work on supporting the data sets, sample data, benchmarking, that kind of thing. There are folks who get much deeper into the software, so but I'm not one of those. So I do some novice workshops and training and that sort of thing. So that's really my contribution, is definitely around the edges versus in the very mathy and physics heavy core of the software. But I can explain it reasonably well, I guess. So you can be the judge of that. I am by trade, I'm an aerospace software engineer. I work for a company out of DC doing primarily aviation and aerospace related R&D. And I also do provide some drone services. I'm an FAA certified Part 107 pilot, and as well as a board member in our local drone related nonprofit. So our industry trade group called the North Coast Drone Alliance. I'm based in Cleveland. I new this year, I'm also an adjunct instructor in the geography department at Lakeland Community College, also here in Cleveland. And I have presented on Open Drone Map to United Nations, International Federation of Red Cross, Hot OSM group, and some other international aid organizations like that. So I definitely have a lot of fondness for that community as well. So just a couple of quick housekeeping notes related to our presentation today. We want this to be fairly informal. If people have questions along the way, definitely please just jump in. When I'm presenting and driving the slides, I can't see the comments very well. So if anyone has a question as I'm talking, please just jump in and interrupt, or if Brett or someone from the SIG can call it out, I'll definitely
monitor the chat.
Happy to address those as we go rather than queuing things for the end. All right. Any questions before we start? All right. Jumping in, what is Open Drone Map? It is a set of software, open source software for photogrammetry that essentially takes photos captured by UAS and turning them into 2D and 3D outputs. So it uses the georeferencing within the embedded metadata of the photos to georeference those outputs, and creates things like orthophotos, digital surface models, digital terrain models, digital elevation model type stuff. This is a GIS centric community today, so we probably won't need to spend a lot of time explaining what those are specifically, but we'll show some examples from the software. Open Drone Map also produces 3D point clouds and textured meshes. And it's a set of tools that's used globally by universities and research programs. Because it's open source software, it's more accessible in certain contexts. It doesn't come with ongoing license or pricing requirements. So definitely good in a research or low budget situation. It's used globally by the Red Cross, by World Bank, and the United Nations OpenGIS team. And the project itself started in 2014. It was a pretty small scale operation for quite a while, but the software itself and the team and community grew significantly 2018 through today. So it's seen a lot of improvements in that time frame. If you had a look at Open Drone Map or were familiar with it from 3 or 4 years ago, I would definitely recommend that you take another look at it, because the precision, output quality, handling of odd circumstances is all significantly better than it was just a couple of years ago. So it's made a lot of great strides recently. And it also has lots and lots of new features, and it's just generally more accessible. Used to require a lot of technical expertise to get it set up and running. You could argue that that's still somewhat true, but it's definitely significantly better than it was with Docker and native installations. And usability of the tools is better as well. So just to be super clear about where this fits in, if the process of collecting data from drones, from UAS, and working those into your analysis involves many, many steps. OpenDroneMap really supports this box here. So it's not a tool that you would use for preparation and planning. It does not manage the flight planning or waypoint setting, mapping, that sort of thing that you do when you're planning out where the actual drone flies. It does not manage the flight either. This is just a set of tools that you would use after you've collected your photos, planned and run your flight, collected your photos. And you can see it steps very lightly into the analysis area. I'll talk more about that. But this is mainly a tool for processing those photos, turning georeference photos into 2D and 3D outputs for use in other tools primarily. Open source is free and open source software. Brett and I are both big proponents of this. It's popular in the settings that I mentioned, academic and research settings, but also commercial settings as well. Open source software is very accessible to programs with limited budgets. Comparing a piece of software like Pix4D, which has an annual cost of approximately $300 to $350 a month ongoing, or $5,000 one time. Sometimes that license is just too much, especially if you just want to kick the tires on it and see if this is if it's a good fit for your program or the type of work that you're planning to perform, or the project that you're working on. OpenDroneMap is free with some caveats. It's open source software, so it's totally available to you if you're willing to put in the work. There are some areas of the ecosystem where you can spend some money and, for instance, have an installer that does a lot of things for you. There are some areas where you can spend money, have some additional convenience for the setup or for the use of the software. But that money goes to the primary contributors of the OpenDroneMap platform as well. So the vast majority of that money stays within the community and supports the software, even if you spend a bit. And it's very, the pricing is very reasonable for those things, as you'll see. But equally important when considering proprietary versus open source solutions for this kind of thing, you have ultimate control over your workflow and your tool chain. You can modify things to suit your program if you're interested in doing that. And you really are standing on the shoulders of giants, essentially, in a lot of these. There's a great deal of effort that has gone into providing quality, reliable software that's also secure, and making that available to the community. The folks that contribute to this sort of application are very community focused. You also have access to the source code. So you have the transparency that you won't necessarily get with a lot of proprietary software. So that you can, if you really want to know what's happening with internal algorithms and calculations, you can dig around there and see that. OpenDroneMap works on a variety of systems, anything from Windows 8 up. There are native installers available for pay. You can also install it pretty easily through Docker for free. Ubuntu Linux is supported either in native or really any Linux format. Any Linux operating system that supports Docker, you can easily run it there. Mac OS via Docker, and Brett, help me recall, I think there's not a native installer.
Not yet.
Okay,
We're working towards that. We do have support for the Apple M chips, so the M1, M2, regular Ultra, but that is through our Docker images and the easy installer, which basically automates the process of installing Docker, configuring Docker, and setting up the dependencies, but it is not native at this point.
Okay, all right, thanks. I definitely, just in terms of what I see in the community, Windows installs and Linux installs are the vast majority. Either Windows native or Windows Docker or Linux Docker is what I see the most. I see a couple of, I see 3 items in the chat. Any of those?
I am dropping links for.
Oh, excellent. Okay, cool.
Yeah, sorry.
Cool. All right, good deal. So further discussion of supported systems. I believe our documentation says that you can use OpenDroneMap with as small a machine as 4 gig RAM. I think that would probably, you would probably find that fairly frustrating. So I wouldn't necessarily take out the old laptop out of the closet as your first experience here. I tend to recommend for people 16 gigs or more on whatever hardware you're interested in installing it on. More is always better. Certainly if you're planning to run larger data sets in the several hundred to several thousand size, you're going to want something more like 64 gigs, 128 gigs, potentially even more. But 16 is a pretty good base level just to get you going, and you can process quite a bit with that.
Yeah, for reference, my documentation and test machine is a 4 gig Celeron laptop. It's very painful. An 18 image data set, Brighton Beach, takes that machine about 45 minutes to process. Mostly because it spends time swapping. So like Corey said, it's not super useful, but we do make sure that it will run. If time's not a constraint, you can let it cook for weeks if you wanted to.
Yep. 50 gigs or more on your hard disk. Free space is helpful. The process does create a lot of files and take up a lot of space during the processing jobs themselves. Those get cleaned up typically, but it can require a lot of hard drive space for processing, even if the outputs are smaller than that. It's good to have headroom on your disk as well. Using the software itself, one of the things you'll find if you look at the OpenDroneMap sites and GitHub repositories and just general resources, you'll see there are several entry points to actually using the software. So it can be, you can use it with a web interface, which is what most people do. That's WebODM. What's actually happening behind the scenes is you'll have one by default, or you might choose to set up several instances of what is really, classic OpenDroneMap, which is a command line driven set of tools. So WebODM provides a nice interface to it. We'll see some screenshots on that. But you can use it as a front end to one or more either local or remote servers. So WebODM manual installation via Docker typically is free, no cost. You go to GitHub, download some things, and you're off to the races. The installer itself, depending on whether it's an individual or organization, will run approximately $60 to about $150. And what that does, you're not buying the software, you're buying the package of tools that allows you to install that easily. So upgrading is easy. The initial installation, just getting up and running so you can test it out, is quite easy too. So that's two options for getting started. WebODM Lightning is essentially a set of software that you would run on your computer just to interact with ODM, but all of the processing happens up in the cloud. So you don't have to have a particularly robust machine to use this. You can use it very portably. You can send rather large jobs up to the cloud for processing. You pay for that processing. So that's, you spend a little bit with the processing, the cloud processing provider there, but it requires less of your local machine. There are also for your more kind of power user situations, if you want to just run this via command line, you can do that. If you want to integrate that into some of your existing tooling or workflow, you can do that as well. There are REST APIs. There's this little piece right here is WebODM speaks to this stack via a REST API. So if you wanted to create a completely different web-based interface, you could do that. It's available to you. I don't know that a lot of people do that, but it's there, and architecturally that's certainly possible. So the place to start that I typically recommend for people is to start with the installer. If you have a little budget, you definitely want to use it. You want to just get going quickly. That's the easiest way to do it. If you definitely want to keep things free, then have a look at the manual installer and Docker, and even that process is not super complicated. So what kinds of images and what's the input data for OpenDroneMap? Typically RGB images from a standard drone camera. Lots and lots of drone models available to support this. There are some cameras are handled better than others, but certainly anything that's sort of modern and widely available, any of the DJI equipment is very well supported. RGB. Multispectral imagery also pretty well supported, depends on the camera a bit. And multispectral is not my area, so I won't be saying a lot about it, but that's definitely a very common use case. We see it a lot in agriculture and related fields. So multispectral imagery, well supported. Thermal, starting to get into thermal. It depends a lot on the cameras, and the thermal imagery tends to be super low resolution and thus hard to stitch and turn into proper 3D outputs. But we are starting to support some thermal cameras. So if you have a thermal use case you're interested in, probably better to ask, but there is a little bit of that. I'm starting to see that use. Large data sets. If you have lots of photos, if you have lots of acreage you're planning to cover that you need to cover, there are some tools within the software that will help you do that. Split merge is probably the big one, which allows you to take a data set, and I don't have a good graphic of a data set, but essentially it allows you to take, for example, 10,000 photos and split it up into groups of 500. And you have some control over how big those sub chunks are. You have some control over what the spatial overlap is. So you have some parameters that you can use to tune how you split that up. And then that job that's been split into sub pieces can be fed to a single OpenDroneMap instance to just be processed sequentially, or if you are using cluster ODM, which is just another tool that you can kind of layer in here if you're interested in this kind of thing. Cluster ODM handles the job of distributing multiple tasks to multiple servers, and so you can run your job. You can split it up in parallel and have it automatically stitched back together at the end, or you can just run it sequentially through a single system and have it stitched back together at the end. Depends on whether you have time or hardware, really, but both can happen. The largest data sets that I'm aware of that are being processed with OpenDroneMap are in the range of 70 to 90,000 images. That's possible. That is not something, that it's not trivial, and it requires a lot of work and a lot of care in the configuration and processing parameters, and sometimes a lot of trial and error depending on the data set. But I have seen some data sets of that size processed successfully.
I believe the 99,000 image data set required 1.5 terabytes of physical memory, and I think 6 terabytes of swap. So
okay, yeah.
Not trivial.
Definitely not. I'll pause here. The next section is we'll get into the 2D and 3D outputs and just some of the user interface. I'll pause here in case there are any questions related to setup or use.
If anyone wants to speak or use the raise hand thing, or just drop it in the chat, whatever's most comfortable.
Okay, we'll forge ahead. So this is WebODM. This is the web-based interface, although it is typically run locally on your local machine, but it looks like a web-based interface and can be turned into one without too much trouble. You'll see on the left, this is just a super simple dashboard. You'll see on the left, there's navigation, very typical software layout. You have a few options related to administration of and diagnostics for the system. If you're connected to the Lightning Cloud Network, this is where you would set that up as well. There's navigation on the left. Then you have a list of projects on the right. These can be named whatever you want. And then below each project, you'll have a set of tasks. So each one of these is a processing job, essentially. So for each of these processing tasks, I've uploaded some photos. It ran the processing job and then gives me the option to either see the logs or work with the outputs.
I was gonna say real quick, the project as like a organizational concept is actually pretty cool. You'll notice next to the project header, there's a view map. So this becomes really handy when you have multiple data sets over a wider physical area. So if you're doing like trials or studies in different regions, if you group them all into one project, you can hit view map and it will render all of the orthophoto or DSM or DTM products at once. So you can see all of your sites sort of, aggregated together. Or you can dive into the individual tasks to just view them one by one. Currently, the view map for the project doesn't support aggregating point clouds or 3D models, however. So it's just for the 2D products.
Good deal. Yeah, thanks for mentioning that. That's a nice feature. Within each task, you have some additional information. You just click the name and it'll pop out this additional info. You can see when it was created, where it was run. This option string could be very long depending on the configuration that you use. There's your average ground sampling distance, total area covered, number of points reconstructed. And then you can see using this task output, you can actually access the entire processing log as well. You can see up here how long the process took, just under 4 minutes, that the status is completed. And so quite a few items related to the actual processing job itself. To directly access the 2D outputs, you can use this view map here. And for 3D outputs, you can use view 3D model. And everything can be downloaded. I'll come back to the download as well. But you can also, everything that's produced by the software, you can also download in some pretty reasonable standard formats. So 2D outputs, primarily, starting primarily with the orthophoto, you can jump in with this view map button here. And that's that's going to give you a visual of the orthophoto overlaid on a variety of different base maps. You can Google Maps, OpenStreetMap, you can use a custom map. Totally up to you. Comes with several very usable ones right out of the box. You can perform some basic measurements. You can generate contour lines, different parameters there. But this just gives you the orthophoto overlaid on your base map. And here's that same orthophoto overlaid on OpenStreetMap. And you can perform some basic measurements.
As a little fun fact, if you're familiar with using Grass GIS for processing, that is what we are using for elevation maps and contours. We're not exposing every option, but that is the engine that's powering these analyses, so it's very capable.
Yep, there's contours. And you can configure a few different things of related to the contours, show them again within WebODM, or you can export them as a TIFF, GeoTIFF. Measurements. There's some pretty basic measurement tools that you can do right within the software. I tend to recommend this as kind of quick analysis. Where do you focus? Or if you just need a quick measurement, you don't need it to be super precise. This is a great place to do it. If you need a higher level of precision in the measurements, you're probably going to pull these 2D and 3D outputs out into other software and do your analysis on either a GIS tool or something that you're already familiar with. But linear measurements, very easy, just point and click. And then you can quickly get linear area perimeter measurements on your orthophoto. Volume, I tend not to credit too much. I think that's something that you're going to want to do in ARC or QGIS or someplace like that, probably. Plant health. OpenDroneMap supports lots and lots of plant health indices. If you're uploading multispectral data, a lot of this gets processed for you pretty much automatically. You have quite a few options that you can adjust here. You can change the color ramp. You can change the algorithm. You can change the highs and lows of that color ramp, the actual color ramp variety here, and you can export again.
A note for using that. We don't fact check what input data you're using. So,
Right.
you know, we're perfectly happy to apply NDVI to RGB data, and that's not that's not real.
Yeah.
But this is a great way if you are interested in contributing. You can always help us add an algorithm. It's not super hard to poke at the Python, and we've helped a few other people make their first contributions that way. And that's actually one of the first things I did. So if you're curious and you want to add a particular index, you know, this is a great way to sort of onboard and learn things and get involved.
Good point. And I think at least one of these indices that's built in is usable in RGB data for vary, if I'm not.
Yeah, the vary.
Yeah. Let's see. Oh yeah, color ramps, multiple color ramps. And then moving on to our DEM related outputs. Again, this is 2D stuff. We've got a surface model, which is just it's very, very top level. So anything that's visible from the sky, from the drone camera, this is going to be a model of that. And as with the plant health, you've got multiple color schemes. You can adjust your min and max. You can set the color ramp to something else if you're interested. And what you would typically do with one of these outputs is export it as a GeoTIFF and pull it into another piece of software, probably like ARC or QGIS for further analysis. Terrain model, very similar. The software does some point classification to remove ground objects, shrubs, buildings, to the extent that it can detect those things. So the DTM is going to be your terrain profile. Again, fully exportable. So this audience, I think, is probably fairly familiar with these, but this is just a visual comparison of the surface model, which includes little building and all these trees and shrubs here, and the digital terrain model, which really tries to get at where's the ground, tries to filter out as much as possible those freestanding items. All right, that's 2D outputs. I'll pause there in case there are any questions on the 2D stuff, orthophotos, etc. All right, how's our time? 12:38. Okay. 3D outputs. This is accessed from a couple different ways. You can either, I don't think I have a good example here. Most directly, you can jump from the task to this view 3D model. You can also bounce between the 2D and 3D outputs. I'll try and show that when it comes up in a later slide. But this is just a basic 3D point cloud. So this is individual points in space with X, Y, and Z. It applies color based on the photos and from the drone, what's in the orthophoto. And this is data that you might export to another tool, such as Cloud Compare or something like that for analysis. You can do some rudimentary analysis within the software itself, but probably, especially if you're doing change detection over time or something like that, you'll be using an external tool. But the data is fully exportable in very common formats. LAS, I think, is our point cloud export. Textured mesh is the point cloud with all of the surfaces filled in with surface triangles. It is colored. You can see the pre-color step here. So it's just a point cloud with the visible surfaces filled in. Those outputs are suitable for exporting into 3D model visualization software. There are several tools that you can use to share them online. You might bring those into CAD. You might put those into another 3D model manipulation tool. You might have a flow that takes this into something that eventually gets 3D printed. So that's the kind of output that you would use for this surface model. And you can do some measurements in the 3D space as well. So their linear measurements are very easy. This, when you're working on the ground, the area measurements are good. There, you can use, because it has the X, Y, and the Z, you can calculate angles, overhang angles. You can look at height, you can look at height profiles, and you can do volume calculations as well. Everything can be downloaded. Everything that I showed you previously here, including, I think, the measurements, can be downloaded. Your ortho photo will come out as a GeoTIFF, terrain model, and DTM, digital surface model. All your DEM stuff will come out as GeoTIFF as well. Common standard formats that are very portable. 3D point cloud is a LAS. The texture model is an OBJ. So none of this is, crazy proprietary vendor lock-in type data. You consider this your data, and you should have full access to it. Camera parameters. There's also a quality report. Most software that does photogrammetry, structure for motion stuff, commercials or open source, will give you a quality report so you can really see what, how things went during the processing job, and have a look at the details of the precision that came out of that.
Just a quick note, we're using COGS, so cloud optimized GeoTIFFs in specific. So those are transparent to software that does not support that feature set, but it's a superset of features that allows for the GeoTIFFs to be queried and streamed and accessed using GET requests. So this would be useful if you're hosting the data online or even locally with a tool like QGIS. It just rapidly speeds up the preview and getting of the data. You don't have to load an entire, let's say, like 2 gig image into RAM. You can just query the spot that's visible and display that immediately.
Excellent point. Yeah, this data gets pretty big. All right, I think that's my last. Oh yeah, just a quick summary of everything that you can get out of it. You can download everything as a single largish zip file. And again, from OpenDroneMap, you're going to expect outputs like orthophotos, surface terrain models, plant health and multispectral data in the 2D space, and then 3D point clouds, texture meshes, and you can download everything in portable data formats. All right. And at this point, I'll keep the slides, but hand the presentation portion over to Brett.
Okay, so we're going to talk about some new things. New is kind of a tough thing because I don't know when everybody last looked at this, but this is huge for us. We implemented rolling shutter distortion correction. So rolling shutter distortion is a type of artifact that occurs on CMOS cameras, which is pretty much everything out there. If you've ever taken a video of like a car or a train or an object moving by quickly, you see it sort of like jelly smears. It doesn't look like the object has maintained its actual shape. And that's due to how the sensor reads out line by line by line by line. And they read out usually very rapidly on the order of 30 milliseconds or less. But depending upon the relationship between the subject being imaged and the sensor, 30 milliseconds can still represent a significant shift. So what that means for us is by modeling and correcting for rolling shutter distortion, this can vastly improve the quality of reconstruction. You can get basically a data set that would reconstruct as garbage and get something very good out of it. It also reduces artifacts. You would typically see this in larger area grid surveys of, like, let's say something like an agricultural field. A nadir survey of a agricultural field at a constant elevation. That's typically what's recommended by most flight planning, but that usually is very poorly compensated for in lens modeling, and it would create a tendency for the data set to bowl. By modeling for the rolling shutter distortion that occurs as you're flying over the field capturing the images, we reduce the bowling, we make dimensionality a lot more true to on ground. And combining that with just good workflow practices like having ground control points, you can get a significantly higher accuracy and precision of your reconstruction. So on the left, we have a quick little video clip of a a very messy, purposefully on ground. So this is not drone based. This is me walking with my phone around a car and just very haphazardly taking photos and not worrying about my subject object distance and stuff like that. So on the left is without rolling shutter distortion correction. And on the right is the exact same data set, just with rolling shutter distortion correction applied. And this just leads to a much cleaner reconstruction. It's still not perfect, but given how I took the data set, the fact that I'm reconstructing down to a perfectly legible license plate, and I no longer have like 5 random mirrored ghost cars all over the place, just shows you how much this can correct and clean and constrain your data set. So if you see on the left, my car is scaled and rotated multiple different times in different directions all over the place, because the lens parameters were not accurately modeled due to poor GPS, reflections coming off the car, and a number of other things. So this is a big advancement for us and aligns us with tools like Pix4D and Agasoft Metashape, which both can do this type of correction. Yeah, next after that one's done. Oop. All right. So we have NVIDIA CUDA GPU acceleration. This is for 2 parts of the pipeline only. And this is for NVIDIA CUDA capable GPUs. In practice, this means something like a GTX 900 series or newer, or a one of their workstation or server cards from around the same time. I believe at this point we're targeting CUDA framework 11.5. It's very hard to find that information. You're going to have to dig into the driver release notes for your card for each version to see what CUDA toolkit they're targeting. But as a, back of the napkin, 900 or newer, you should be good to go. So for the feature extraction part, which happens in the beginning, that's when you are taking the images and trying to extract unique identifiable objects from the pixels. We can do that with the SIFT feature descriptor only. And in application of this, we've sort of run into CUDA texture dimensions are a little bit different than your image texture. So let's say your graphics card reports that it can handle a texture of, 65,000 pixels per edge. That needs to be taken into account the band numbers and the bit depth. So it's not necessarily that you can load like a 200 something megapixel image and have it process on your GPU. In practice, it's probably closer to a 16 to 20 megapixel image. But when you do have appropriately sized hardware and data, this particular phase can be very, very time intensive. Typically runs 2 to 3 times faster than on CPU. And then later in processing during the point cloud densification, where we're building that point cloud to then generate the 3D mesh and other products, that phase runs about 10 times faster. So on a small data set, you may not notice that much of a difference, but on larger data sets, that could knock off hours or days of processing. So very, very important, but again, only for NVIDIA CUDA. So this precludes usage on any Mac, unfortunately. Works well on Linux, works well on Windows. We are looking at options like Intel Cyclomatic, which is a tool that allows your GPU or processor to transcode CUDA into native OpenCL and Vulkan code to do the same type of math. But that's very nascent technology, and that'll probably be a year plus before we actually start trying to trial that. So we also have added artificial intelligence and machine learning sky and background masks. So sky masking automates the process of sky removal. This is critical for things like non-nadir imagery. If you're doing an orbit of a cell tower or another type of built infrastructure, you're going to have a lot of sky in the background. Prior to automated masking, you would need to create a empty 1-bit image file and mask the areas you want to exclude in black and the areas you want to include in white. It's very powerful for refining the reconstruction, but it's incredibly time intensive. So with AI ML sky masking, it will do that for you. You just toggle a flag and let your computer do the math. We also have background masking. This is most helpful in situations where you're doing a reconstruction of like probably something handheld or something, you know, not, I guess, sort of like world or field scale. So it'll try its best to remove parts of the imagery that don't look like it's the subject or focus of the image. And we still have obviously the ability to do manual masking. So if you have a tricky data set or you want to constrain things, not include other areas, you still have the flexibility to do that as needed. Oh, and I am gonna just show real quick on my end. So this is a shot of, again, a ground level, really sloppy capture from my phone of a northern catalpa tree. So I use the sky and background masking to constrain the reconstruction. It took out all of the sky and filtered out the farm field and everything else that was behind the tree trunk, which was mainly what I wanted to orbit and look at. Did it do a perfect job? No, but I didn't have to spend hours masking it. So it can be fit for purpose, and it's trained against non-organic objects mostly. So if you are, like I said, cell towers or other built infrastructure, it's a much more appropriate use. But I still thought this was pretty neat, just showing off how easy and quick this tool can help constrain your data set and make a nice clean model. Okay. All right, so other random improvements that we've made. We are focusing a lot on trying to make this tool fast and more efficient. In light of that, we've added Apple M CPU support for the Docker builds. Again, we don't have native quite yet, but we're working on it. We also added planar reconstruction. This is a type of structure for motion reconstruction similar to Pix4D fields. It's orders of magnitude faster than doing a full 3D reconstruction and figuring out all the camera parameters. So it's 4 to 6 times as fast, depending upon your machine. And this is most appropriate for a flat scene at nadir. So flying an agricultural field, something where you don't have a lot of Z variation, and you just want to get, a nice orthophoto in DSM. This would be a tool to help you, do that as long as you don't need or want those 3D products. But it does require EXIF metadata, because we are not modeling the camera positions and intrinsics as tightly. So we're relying a lot on the GPS position. And if your platform puts in like yaw, pitch and roll of the drone or the camera, that also helps inform this and helps speed up the reconstruction. We've tweaked our orthophoto generation to improve speed of reconstruction. It's about 1.25 times as fast. It doesn't sound like much, but on large data sets, again, this could be hours or days. Locally on my Brighton Beach data set, which is roughly 18 images, it knocks about a minute off the entire processing time. So I go from like 5.5 minutes to about 4.5 minutes. So you can see how that would scale on a much larger data set. Similar to that, we've added median chunked interpolation for DEMs. This is about twice as fast for interpolating the DEM and DSM products. Again, significant time savings as your image count and study area goes larger. And we've tried to improve our orthophoto alignment. We did this by making sure that raster cells are of a solid size and arrangement. So as you're getting into like subpixel, like you're viewing at, 1-to-1, you won't see a shift over your GCPs or other products. So continual improvements. We're, as Corey mentioned early, we're constantly evolving. If you looked at us years ago or processed something years ago, even a half year ago, run it again. You might be, I hope, pleasantly surprised by the quality of reconstruction and, the speed of reconstruction. We're getting faster. We're generating denser point clouds while still being faster. We're getting more extensive and complete reconstruction areas. So we're reconstructing more of the total scene. And we're getting better at estimating and reconstructing camera parameters. So you're getting a finer spatial resolution out of your data after reconstruction. So if we look at the bottom on the left, ODM 2.4.10 was the first version that we supported putting these parameters into WebODM to show you the data set summary. So I chose that. So it took about 4 minutes and 57 seconds to run on this machine. We estimated a GSD of 1.64 centimeters. We constructed around 7,000 square meters, and we constructed just under 1 million points on the point cloud. So the exact same data set, same machine, same parameters. On our current build, we knocked off about 30 seconds. Our GSD changed by about 1 to 2%. Total area of reconstruction moved a little bit, not too much, but the density of our point cloud increased a lot. So we went from 964,000 points to 1.3 almost million points. So depending upon what your scene is, this can be significant. We've had a lot of positive compliments on infrastructure, taking surveys of building sites, getting columns and stockpiles that previously would be filtered out or not reconstructed before. One of the things that prompted this was someone that was inventorying their vineyard, and they couldn't see the vines. But after some tweaks and help from them to implement this, now we could see their vines and all their grape plants growing. So again, check us out, run it again if you ran it a while ago. And this is something I do just to keep myself honest. Every time we tag a new release, I run the same data set with the same parameters, and I look at how long we're taking and what our reconstruction looks like. How complete are we getting in terms of total area? What's our GSD looking like? And how many points are we reconstructing? And then I'll go in for the, qualitative analysis, look at the orthophoto, look at the DSM product, look at the point cloud, look at the model lake, to make sure that we're not regressing and we're not, introducing changes that might break someone's workflow or lead to a disappoint. And in general, we're doing good. Sometimes you'll see a point, 2.9.2. Well, we had to make a fix. So check for those point releases and stay up to date if you can. The community is a growing and vibrant, and I think incredibly welcome space. That's actually how I got involved with Open Drone Map. I got onto the forum, I lurked, and I saw these incredibly brilliant people from all over the world working in all different professions and at community level, doing awesome work, sharing their knowledge, and helping each other. And it just sort of engaged me to spend pretty much all of my free time on the forum, learning and trying to help other people. So that eventually led to my job doing that. And now I get to do what I love, and I get to help people from all over the world, and they get to help me. It's great. So this is year to date. We have, 1,600 new people, 1,500 new topics, 11,000 new posts. We're getting a lot of interactions per day. It's up 16%, 18 plus people per day, typically engaging. So not just coming to lurk, but like actually helping, posting. And, we're just growing, and I really want to invite everyone to join it, check it out. If you are playing with Open Drone Map, you have questions, search first. We have a pretty good search tool. I really like the forum software Discourse. It's very intuitive. It's very responsive. You can search, you can bookmark, you can take notes on things. And like I said, I check that daily. I sort of fell off a little bit this summer because of personal family emergency, but I'm trying to pick back up. But in my stead, other members of the community have stepped up and gone above and beyond to help each other. So please check it out. I'm going to post a link here. I'll do it in a little bit toward the end. I'm going to post a link that has an invite code, so don't feel weird if you see it's not just a link to the website, there's a string after it. That invite code will promote your trust level, so you don't have to worry about, I can only post one image, I can only post one link. This is where we are. We don't have an official presence on Matrix or Discord or anywhere else. We do have a Twitter account for major announcements, but this is the way to interact with us. Along those lines, I'll put my email later if you need to, talk to me directly. You can private message me on the community. If anything is not welcoming or you have another problem, please let me know immediately. It's very important to me that I help foster an environment where everybody can contribute and feel welcome. So if anything doesn't sit right with you, don't be afraid to let me know. And if there's anything I can do to improve that experience, again, let me know. The next one. This is the wider Open Drone Map community or ecosystem. Corey talked about suites of tools. So we have Open Drone Map, which is the command line processing, WebODM, which is the interface for it. NodeODM is the REST API to talk between different components. LiveODM was a project where we would have an Ubuntu LTS environment on a USB stick you could boot into and process from without having to install everything and set things up on your machine. This has sort of fallen by the wayside. If you or anyone you know can help us update and maintain that, that'd be great. CloudODM is a command line tool to interface with our Lightning instance. And we have a bunch of other things, but what's really cool is we've added on community backed and started initiatives like Field Image R and Find GCP, which we just talked briefly about. So Field Imager is a toolkit for semi-automated stand counts and object detection and extraction using the R statistical analysis and framework. So we have an example of input orthomosaic, and on the right we have an basically centroids found and counted and other metrics derived depending upon how you want to run the analysis. We get a lot of questions about having this integrated into WebODM, but we're not looking to be a full integrated GIS suite. But this team who created Field Imager stepped up and created an incredible framework for this type of analysis. So if this is something you're interested in, please check them out. Along those lines, we also have Find GCP. So this, if you've worked with ground control points and tagging them manually, you will probably appreciate this. This is another semi-automated toolkit for finding, tagging, and generating Aruco markers, which are a specific type of binary feature marker. It just looks like big chunky pixels. So you can create them using this tool, get them printed at like either a print shop or a fabric shop, put them onto a mat, lay them out into your survey area, fly your data, and then run the detect tool, and it will automatically tag by reading the marker, what marker number it is, and then write out the geolocation for it so that you can use them as GCPs without the manual process of going through all the images one by one. Can I see marker 4? Click on the center of marker 4, write out the locations into a text file. So this basically removes all of that load from you and allows you to use ground control points, which are an incredible best practice, in a much easier way. The website also has guidelines for how to print them, what materials to make them out of. Some people use vinyl tiles from, Home Depot, so it doesn't have to be expensive. They also provided us with a GSD calculator. So you put in your sensor, your flight height, and things like that, and it'll help you figure out what your expected ground sample distance is. That's very important if you have requirements for your spatial resolution and what you want the data set to be, to keep that in mind. And I believe, learning more. Docs, I'm responsible for these. So again, I'm going to give you my contact information. If you want to yell at me, please go ahead. These are expanding and evolving. I want to make it into a spot where you can look up a parameter and a flag and, basically have a who, what, when, where, why. Who is this for? What is it actually doing? Why would I want to use it? Why would I not want to use it? And then show you like, okay, if you turn it down to 0 and crank it up to 11, what impact does that have on our data set? So that's my goal for the parameters, because we have a ton and they're not necessarily self-explanatory and they're very powerful. So they could transform how you work with the tool and what you get out of it, but it's a lot to learn. And I don't think it's reasonable for everybody to dive into this stuff and learn all of it. Like, I love it doing that, but that's not a good use of everyone's time. So again, if you go into the docs and you see something that's not obviously missing or incomplete yet, and you think it can be improved, please let me know. Let's see, next, what do we have? the book. So this is a nice, open, lengthy guide to the photogrammetry and structure for motion concepts behind OpenDroneMap. This is mostly focused around the 1.x release, so it will not touch on a lot of things that we've added since, but it is still a great primer. It can be purchased as an ebook or printed on demand through Barnes & Noble and Amazon, and all the proceeds go to Piero Toffanen, who wrote the book, who is the lead developer of OpenDroneMap. So like Corey mentioned before, this is an optional thing if you like it, that you can purchase to help fund development. And we also have policies for people who might have financial hardships or are working in certain not-for-profit contexts, that we can help them out with these types of things. And then again, that'd be something to email me and Pierre to talk about. We don't want to put anything behind a paywall, so we want you to have this. And my goal again with the docs is to basically transform this book into our documentation so that everybody has access to it. Here's the community forum. I will drop a link in the chat again with the invite so that you get a promoted trust level, but community.opendronemap.org. Simple sign up. If you have a GitHub account, you can link to that. If not, email, password. We're not going to spam you. You might get an email digest if you miss a notification, but you can always tune that very easily. And the software, when you sign up, will walk you through how to use it as like a little game. So it's very, very easy and very friendly to use. So yeah, that would be it for me. Oh, Corey's got my contact info, and I will drop that link to the community with the invite. I don't know if anyone has any questions, or if Corey, you want to have some time. Sorry.
Yeah, no, I have time to stay on for sure. I'm good until 1:30 if people have questions, or for the next 23 minutes, I'll say. Probably not everybody's on our time zone, but yeah, I'm good to take questions, and feel free to reach out to either of us. There's Brett.
So we have the link in the chat with the invite, my email. If anyone has any questions, raise hand, drop it in the chat, or just go ahead and let us know.
I think we could make these slides available too if people are interested in a copy of the slides.
Yes, yeah, we'll find a spot to make them available. I don't know the best way to coordinate getting that back out to everyone. Maybe we'll do through the email you signed up with. Or if you go to the community, I do have a post about this session there. I can always link from the community. So that should be pretty easy to find.
All right.
Thanks everyone for attending, and oh, there we go. Beautiful. Thank you, Justin. Justin understood that he can post it on the GIS SIG website. So that also is a great discoverable way to do it. Yeah, thanks everyone for attending. Feel free to reach out. I hope to see you. I hope to see your projects and cool stuff you're working on. Go crazy, grab your phone, grab your GoPro, walk around. You can do so much and just have fun with it.
All right. Thanks, everyone.